So there's two main types of drag that an airplane experiences. We have parasite drag and induced drag. So parasite drag is drag as a result of air resistance and friction as the airplane moves through the air. And so the faster the airplane is going, the more parasite drag it experiences. So on a graph of drag versus airspeed, parasite drag might look something like this. It's pretty low at low airspeeds, and it gets more and more and more as airspeed increases. We also have induced drag. Induced drag is drag that occurs as a byproduct of lift. Anytime the wing is producing lift, there's also some induced drag. Exactly how that works will be the subject of a different video, but just know that induced drag increases with increased angles of attack as the wing produces more lift. So as airspeed decreases, induced drag is going to increase. So this line here can represent induced drag. So at low airspeeds, when the airplane is at a much higher angle of attack, induced drag is significantly increased. And as the airplane's airspeed increases and the angle of attack is reduced, induced drag becomes less. So adding induced drag and parasite drag together, we get the total drag that the airplane experiences. And a graph of that would look something like this. So you can see that it has a low point here, it increases towards the lower speed end and also increases towards the higher speed end as induced drag increases here and parasite drag increases here. So at this point here, where the total drag is the least, the airplane is producing the most amount of lift for the least amount of drag, so we say it has its maximum lift to drag ratio here. This is the airspeed that's going to provide you with the furthest possible range. So this is the airspeed for maximum range and also the furthest possible gliding distance in the event of an engine failure. Notice that as airspeed decreases, the total drag starts to increase again from the maximum LD point, and that's because of the rapidly increasing induced drag as airspeed decreases and angle of attack increases. So at these very low airspeeds, we actually have more drag than we do at somewhat higher airspeeds, and it's going to take more power to maintain these really low airspeeds. So that's why you'll notice in slow flight, it actually takes more power to maintain a steady airspeed than it does at a little bit higher airspeed.